Okay, I've been working on my vintage milling machine. Here are the oilways. I've removed one of the oiling points here, cleaning it out, and I discovered that the hole goes all the way through the casting into thin air. So I think that's a manufacturing problem. So the question is, what am I going to do about it? Well, welcome back to Workshop Friend. It's been a while since I put a video out, and that's because I'm starting a new series, and I recently acquired this Adcock and Shipley milling machine. The oilways that I just showed you are off the saddle, which fits on top of here, and I'm going to be renovating this machine over the next few weeks. I actually brought it here in pieces. I dismantled it on location using this engine hoist. I was able to load it into the van and bring it here. It's quite a weighty beast for my size of equipment anyway. This weighs around about 810 kilograms when it's all fully equipped. In its empty state like this is around about 600 kilograms. So it's quite a lot to move around, but I've got it into position in the corner here, approximate position, approximately leveled. I'm going to continue to reassemble it, and we'll go back and have a look at those oilways on the saddle and see what needs to be done there. So one of the first things I noticed when I took this apart was that all the oilways were filled with grease, and this is exactly the same problem I found on my Colchester student lathe when I renovated it. So it should be oil, and so I've cleaned out all the channels, and in so doing I discovered, I was trying to work out actually how the oil gets to the various parts. So these two lubricate the bearings on the lead screw. This one is for the gearbox. There's one here and one on the opposite side which lubricates the slideways. And so the oil is distributed to 3 points and into the corners of the V there. And what I found curious was that the oil that goes into this point, the easiest path out of this is actually just downwards into free air. There's nothing below this at all that needs to be lubricated. So that to me looks like it's a mistake. Beneath this there's a thin wall, and it just seems to me that the drill went too far and went right the way through the material. So I've got the casting upside down now, and you can see here this is the oil feed hole, and that's where it's broken through into the underside. So what I've done is to make a little plug. This is a M6 thread, and I've had to just sort of taper the top end so that there's enough room to get right beside the edge of that casting there and get it to screw in. So I'm going to just clean out the hole with some alcohol, methylated spirits, clean this up, and then screw this in with a little bit of thread lock, and hopefully that will block the hole up and make sure the oil goes in the right direction. Okay, it's time to clean out the thrust bearings for the cross slide lead screw. I'm going to do this in 2 stages because they really were extremely dirty. Okay, I'll replace this with a set screw later, but for now I'll just put this socket head cap screw back in. So we are getting to the stage now where we can start to put the feed screw back in place. I'm going to give these bearings another clean. I've given them a rough clean, but there's a lot of swarf trapped in the whole assembly there. Very, very fine, dusty swarf, and it just gets into everything. So I've cleaned all that out. This is now functioning more smoothly and certainly looks a lot better. So we'll put that on one side. So we'll come back and have a look at the lead screw nut. It's a very hefty bronze casting, and this is the locking mechanism. We can remove that. I'm going to give this similar treatment, give this a clean, and then get a closer look at this. There's an adjustment mechanism here with, it looks like a shim in there. So I don't know if that's original spec or whether that's been added. I think it probably is. I would imagine it's slotted, so you can release these pinch screws, slide that out, and maybe reduce its thickness slightly and put it back in again. That would certainly give a much more solid location. So this end is in other words, it forms a whole circle rather than a split. Okay, we'll leave that to soak and come back and have a look at that later. Lead screw nuts are a little difficult to fit because, as well as having 4 bolts and 2 dowel pins for location, there's also the locking mechanism. And originally I thought the dowel pins were there just to hold the lead screw nut in place, but there's also considerable force from the locking mechanism, so those dowel pins are important. So here I am fitting the Y-axis lead screw. A little bit fiddly because, as well as fitting the 2 thrust bearings, I've also got to thread on the 2 locking nuts behind that and screw into the to the cross slide nut. So that requires a little bit of fiddling around, as you can see here. At this point I wasn't so much interested in the backlash in the lead screw, but more whether the table is moving squarely without any rotational movement. Okay, just double checking now that the oilways are clear and oil is getting to where it should get. Okay, you see the oil coming out there, and it will run into this distribution point here and here, and at the center one it actually drops down onto this member here, so provides a lubrication at the front on this slide, and similarly on the back here. Yeah, so that's coming out there now nicely, not dropping down below as it was before, and that also will drop down onto this slide. So I'm happy with that now. I think we can move on to the table itself. Now, according to the handbook, these bearings should be fed with grease, but the grease has dried up and the channels are again blocked, so this needs to be cleaned out. The reason this is a bit fiddly is because I've got to engage the keyed part of the lead screw with the drive dog, and that's just dropped down here. So I'm going to lift it up and then eventually get it to push through. Okay, in preparation for fitting the gib strip, this is a tapered gib strip, and it's positioned by these two set screws on each end, and they just catch in this notch here, and either tighten it or release by pushing the other direction. So you undo one and tighten the other. So in preparation for that, I just had a look at the two screws, and one of them was slightly damaged. So this is an example of the kind of work I've been doing along the way, and I haven't shown it all on camera, but this screw was just slightly bent, so that in operation it wasn't giving smooth movement on the gib strip, and also the end was damaged. So I just slipped it in the lathe and turned this underside here and reformed the outside and reformed the chamfer there. So that's now a lot smoother, and I think we're nearly ready to fit the table. This is really where I could have done with a little help. Initially I tried to fit the table from the wrong end, and then I realized that actually it only goes on from the other side. So now fitting the tapered gib, just applying a little oil, everything is ready for it to be installed. Eventually, after a bit of trial and error, I was able to get the right adjustment, manipulating the screws at both ends of the gib. I'm starting to work on the counter shaft. This is the back plate that goes in from the rear of the machine, and it's kind of on an eccentric, so it pivots like that, and so adjusts the belt tension between the counter shaft and the head. And the other tension is achieved by moving the motor. You see, it's a very heavy job. Like everything on this machine, it's solid. So I don't think there's anything to do to this except just clean it up, and I should put it all together. I'm not going to open the bearings up. I don't think there's any need to do that. If there's any problem, I can look at that later. So my philosophy with this is to get the machine going and deal with the obvious issues. And now I know how to assemble it and disassemble it quite quickly. I can hopefully focus on anything that needs attention later on. So I'm just going to go ahead and keep cleaning this and make it a bit more comfortable to put together, and more convenient to disassemble later if it's in a clean state. I think one of the advantages of disassembling a machine to shift it is that you get a good opportunity to have a look at the parts, both when you disassemble it and also when you put it back together again. And already I've been able to put right a few minor issues. Basically the machine is in good condition, and so I'm going to finish assembling this, which is from the rear of the machine, a bit difficult for me to show you, and then I'm going to start working on the motor. So here's the feed pulley for the table feed from the back of the machine, and it has a couple of universal joints and a spline shaft. So again, nothing much to do here, just clean it up and get it ready to reinstall. This is where I've got to with reassembly. So I have installed the motor. The motor is 2 horsepower and is actually quite heavy motor for the power output. I'd say it's 50% heavier than my 3 horsepower motor which I have in my Colchester student lathe. Anyway, that's installed. I've also used the original conduit path for the wiring, so that comes up through the center of the column and emerges at the top here. So I've got three wires in there for 3 phases, plus an earth wire which is connected to the body of the motor. I'm going to put the variable frequency drive, the single to 3-phase inverter, around about this position on the right hand side of the machine, which is more convenient. And I'd like to try and use some of the original contact switches there for controlling the motor. Initially just the drive motor, but maybe later on the coolant pump as well. Slight problem with that is that these are contact switches, not on-off switches, and I think the variable frequency drive has ports which require on-off switches, so I'll need to work that out. And then you can see down here the drive for the power feed. I've installed that. So the counter shaft is in, the belts are tensioned, and the belt tension is affected here on the back here by slackening this off and then rotating this plate which holds the countershaft spindle. This also, the drive has a cover which I need to install, so that's coming on next. And here's the suds pump. Not going to use that at the moment because I need to have a second variable frequency drive. You can't run 2 motors off one, so I understand, so I need to think about how to solve that problem. Initially I won't need it anyway. Well, the machine's reassembled. It didn't take as long as I thought it would, actually. So I've got everything back together more or less as it will be. Of course, some adjustments are required. For example, the gibs need to be finely adjusted. I need to get some more oil nipples and grease nipples so that I can make sure the lubrication is kept up. And the variable frequency drive is in, that's running. One other small thing is the dial on this is the x-axis, that I can't release it to adjust it, so that needs to be sorted out. Anyway, we'll zoom in a little and we'll see it running. So first of all low speed. There's automatic cut off here. And then we can change the ratios for the feed. Now, of course, there are actually 18 speeds on this. This is on the 2 middle belts. There's 2 sets of belts, so that gives 9 speeds with the belts, and then you've got the back gear, so that gives a total of 18 speeds. So it's kind of in a mid-range at the moment. We'll just run it on the high speed, and you will see something that's a little bit amiss there, I think. So we'll start on a low frequency, we'll just run the speed up. Well, unfortunately, there's some bearing noise there. So I'm going to have to take the head off and do a thorough investigation. I hope it's not the bearings at this end. I'm hoping it's the bearing at the other end. But anyway, you're going to have to look at that. So there's something not quite right there. So that's going to have to be the subject of another video. I'll start looking at the bearings now and see if I can ascertain what's required and maybe source some new bearings before next time I use the workshop. So anyway, thanks for joining me, and I hope there's been something interesting here for you.